Today I have a dot matrix. I'll start with an example, then explain a bit about how it works. So it has two methods of operation. It has a D-pad and a keypad. It also has an enter button, a save button to save individual dots, a delete button to delete individual dots. These two buttons here are control whether or not you're in keypad or in D-pad mode. And this button here basically just resets everything and restores everything to the default. So to select positions on here, instead of doing something like F6, which on this is a 64 dot matrix, I guess, F6 would equate to 46. So instead of putting in F6, I can just type in 46 and hit enter. And that would go into what would be the equivalent of F6, which is A, B, C, D, E, F, 1, 2, 3, 4, 5, 6. So each row is 8 dots long, and this would be 8, 16, 24, 32, 40, 48. So 48 minus 2 is 46. I can then save that dot, and if I hit the keypad button again, I can enter a new number and hit enter. So I'll put in 19. So that would be 16, 17, 18, 19. I can then save that number, and I'll put in 32. And I'll save that as well. And now I'll change into D-pad mode. So I can now move around the board freely. And let's say I don't want position 19 there anymore. I can just delete that and continue doing whatever I was doing. And when I'm done, I just hit delete and everything resets. So basically what it's doing is this orange unit here is taking everything in as decimal and converting it into binary. It's then saving each, it's saving each binary digit into a shift register that's capable of shifting 4 bits at a time. So if I were to enter, say, a 1, it would save that 1 into the first 4 bits. Then if I were to enter a 2, it would shift that 1 into the next 4 bits and save the 2 into the first 4 bits. Essentially, that gives me binary coded decimal, because the 1 would then be in the tens position and the 2 would basically be in the units position. So I can then convert that BCD, or binary coded decimal, into binary again and send it into this divider here, which divides any number that's coming in by 8, which is the length of the rows, or the square root of the total of dots. And if the number basically isn't equally divisible by 8 or is under 8, then the remainder tells this OR gate here to add 1 to this binary, what am I saying? This adder, which then adds 1 to this binary counter here, which these binary counters are responsible for the D-pads. So I can increment and decrement the positions using the binary counters. The number then goes out into this binary to decimal converter, and basically these are responsible for the rows along here, and its default is 0, 0 basically, which is the bottom one here, which would be 0, 0 is essentially 64, is equal to 64. So it pretty much just starts on 64. So if I were to say put in a number down here, we'll do 12, like the example, and I'll hit enter. So this is outputting a 12. 12 is then going into this divider here. So 8 does go into 12, which means this, and it also has a remainder. So this is putting out a 1 because there is only one 8 in 12. So this puts out a 1, but because there's a remainder, it tells that to add another 1, telling this to go into row 2. And then the remainder tells this one here which position in row 2 that it needs to go to, and that will give you the dot. So here, these are basically just wired into, well, they're wired into the outputs so that I can control each individual, like save and delete. So there's a lot of AND gates and OR gates around here just so I can control each individual dot with the save and delete button. And yeah, that's pretty much about the size of it. That's about how it works. So I'll just quickly reset it here. And yeah, so you can pretty much just use this to draw like silly little pixel art pictures. It's nothing really super fantastic. Just draw something silly. Draw a bad little face. There we go. So yeah, nothing really all that fantastic, but yeah, just something you can use to mess around with. Yeah, thanks for watching.